Hello, Mr. Richards here. Today's lesson is called Solving Inequalities. You'll learn how to solve inequalities by using the addition and subtraction properties of inequality, and how to solve inequalities by multiplying or dividing by a positive or negative number. Let's first deal with our first key concept, which is addition and subtraction properties of inequalities. I think we can all agree that 6 is less than 9. Now, what the addition property of inequality states is, if I can take a number such as 3, and if I add that 3 to both the left and the right side of my inequality, and then simplify, my inequality is still true. 6 was less than 9, I added 3 to both sides, and 9 is less than 12. That's the addition property of inequalities. I also think we can agree that 10 is greater than 5. Now, if I take the 10 and the 5, and I subtract the same number, say 2, from both sides, I have 8 is greater than 3, which is also true. So I have the addition property of inequalities and the subtraction property of inequalities. Basically, I can add the same thing or subtract the same thing on both sides of an inequality, and the inequality will still be true. We can use these two properties when it comes to solving inequalities. So we have y plus 5 is greater than 11. Well, we're going to solve these very similar to how we solve equations. If I have y plus 5 is greater than 11, our first step here is going to be to move this plus 5, so I need to subtract 5 from both sides of my inequality. This cancels out, and I'm left with y is greater than 6. Now, our check step for inequalities is a little bit different than our check step for equations. We will still start by rewriting the original inequality, y plus 5 is greater than 11. But instead of just substituting the number 6 in for y, we need to pick a number that is true for the inequality. So if y is greater than 6, I need to pick a number that is greater than 6, such as 7 to put in for y, since 7 is greater than 6. And when I go 7 plus 5, that is 12. And 12 is greater than 11, so this checks out, and my answer, y, is greater than 6. What about h minus 1.5 is less than 5? Let's rewrite this here to give ourselves just a little bit more room. H minus 1.5 is less than 5. We need to get our h alone, so we will add 1.5 to both sides of our inequality. This cancels. We're left with h is less than 6.5. Now, let's check this. Start with our original inequality, h minus 1.5 is less than 5. Now we need to pick a number that's smaller than 6.5. How about 5.5? Since 5.5 is less than 6.5. Minus 1.5 is less than 5, and we get 4 is less than 5, and that checks out. So our solution is h is less than 6.5. Now our directions actually said graph the solution on a number line, so you did not need to check this, but it doesn't hurt. Too much at least. So if you put an open circle at our point 6.5, and then pick a number smaller, we can go 4, and pick a number bigger, we can go 8. If we have the open circle at 6.5, ask yourself now, is 4 less than 6.5? Yes. Is 8 less than 6.5? No. So we're going to draw in our inequality towards the side that is true. Now, we picked 5.5 for our check step. Does that fit in here? Yeah, it's right around there. Now, can we divide in a word problem? Joey is going bowling and has $25 to spend. Write and solve an inequality to find the maximum number of games he can bowl if each game costs $3.75 and he buys his snack for $2. Well, let's write and solve this inequality first, but before we do that, what is our variable? What are we looking for? Well, we're looking for the number of games he can play. So if we say G is going to be equal to the number of games, we can then set up our inequality. So he has $25 to spend. We'll deal with that next. Each game costs $3.75. So we're going to take $3.75, multiply that by the number of games he's going to play, G. We have to include the snack for $2. And now that's going to be actually less than or equal to 25. Why less than or equal to? Well, the number of games he plays times the cost plus his snack. It can be equal to 25, but it needs to be possibly less than. So less than or equal to. He cannot spend more money than $25. He only has $25. Now to solve the inequality, subtract 2 from both sides. This cancels. We're left with $3.75 per game. Is less than or equal to 23. Then divide by $3.75 on both sides of our inequality. And we are left with G is less than or equal to 6.13 with this 3 repeating. Well, basically, he can bowl 6 games. He cannot bowl the 7th. He would go and spend too much money. So 6 games is the maximum number of games he can play. Now we do have multiplication and division properties of inequalities. Now, let's pretend we have the numbers 2 and 4. Well, if I take this 2 and I multiply it by a positive 2, and I take this 4 and I multiply it by the same thing, a positive 2, our result is 4 is less than 8, and that is still true. What if I have 4 is greater than 2? And I decide to divide both of these by, pick a number here, 2. We have 2 is greater than 1, and that still is true. So when I'm multiplying or dividing by positive numbers, I still get true inequalities. Let's start off, though, again with another inequality. 5 is less than 10. And if I take my 5 and I take my 10 and I multiply these by a negative 2, does our inequality still hold true? Well, 5 times negative 2 is negative 10. 10 times negative 2 is negative 20. What inequality symbol do we need to write in there? Well, negative 10 is actually greater than negative 20. And that is a multiplication property of inequalities. When you multiply both sides of an inequality by a negative number, you have to do what's called reverse the inequality sign. So when you multiply both sides of an inequality by a negative number, you have to reverse the inequality sign so the inequality can remain true. Will this work for division? Well, if we have 12 is greater than 6. Well, if I take my 12 and if I take my 6 and then I divide both of those by a -3, well, 12 divided by -3 is -4. 6 divided by -3 is -2. And actually, -4 is less than -2. So also for division with negative numbers, if I divide both sides of an inequality by a negative number, I need to once again reverse the inequality. So when you have positive numbers being multiplied or divided on both sides, you reverse the inequality. But when you take a negative number and multiply or divide on both sides of an inequality, you do need to reverse that inequality. Solve the inequality, graph the solution on a number line. Let's go ahead and rewrite this. -9x is less than -27. Well, let's divide by the -9 on both sides of the inequality. This cancels, and since I divided both sides of the inequality by a negative number, I need to reverse my inequality. So I'm left with x is greater than 3. Now it does say to graph, but let's go ahead and check this as well. If we check this, -9x is less than -27. Pick a number that's greater than 3. Well, 4. So -9 times 4 needs to be less than -27. Is it? Well, yeah. -36 is less than -27. So it checks out, as does our solution of x is greater than 3. And when we go to graph this on a number line, we'll start with the open circle at 3. A number larger is 4, a number smaller is 2. And again, with that open circle at 3, test your numbers. Is 2 greater than 3? No. Is 4 greater than 3? Well, we just proved that it was, so yes. And so we're going to shade towards this side that is true. Now, what would happen if you forgot to switch your inequality and you had x is less than 3 for your answer? Well, when you went to check it, -9x is less than -27. Pick a number less than 3, like 2. -9 times 2 needs to be less than -27. Is -18 less than -27? No. So your check step proves that you have to reverse that inequality for it to be correct. So make sure when you multiply or divide both sides of an inequality by a negative number that you reverse your inequality sign. And now we have a two-step inequality. -x divided by 5 plus 4 is greater than or equal to 11. Well, our first step here is to subtract 4 on both sides. This will cancel. And we're left with -x divided by 5 is still greater than or equal to 7. Notice, when I'm adding or subtracting, this inequality sign does not reverse. It's only when I multiply or divide by a negative number on both sides. Well, the reciprocal here of x divided by 5 is -5 over 1 times that, times -5 over 1. And so this cancels out, and we're left with x. And since we multiplied by a negative number on both sides of the inequality, x is going to be less than or equal to -35. And again, it doesn't say to check, but again, it doesn't hurt to check. If we rewrite our original inequality and pick a number that you're going to be dividing by 5 that's smaller than -35. Well, how about negative 40? So the negative of negative 40 over 5 plus 4 needs to be greater than or equal to 11. So the negative 8 plus 4 is greater than or equal to 11. Well, this whole negative thing just turns into an 8 plus 4 needs to be greater than or equal to 11, and sure enough, 12 is greater than or equal to 11. So this checks out that x is going to be less than or equal to negative 35. To graph the solution on a number line to finish this up, we'll have negative 35, number smaller, negative 40, number larger, negative 30. We'll start with the open circle at negative 35 and test. Negative 40 is less than or equal to negative 35. Negative 30 is not. So we're going to shade towards the negative 40. And when it comes into filling the circle or not, is negative 35 less than or equal to negative 35? Of course it is. And that is our solution. That is it for this lesson on solving inequalities. Be sure to pay attention to when you're multiplying or dividing both sides by a negative number. And good luck.